Hello students, welcome to this module number 5, that is other materials and material selection. So in this video we are going to discuss about applications of plastic, failure of plastics and other materials of optical and thermal materials. Okay, so let us begin with these applications of plastics. Okay, so this application of plastic, wide variety of applications by using these plastics. So, for example, we have categorized the based on thermoplastics and thermosettings. If you consider thermosets, so suppose if you take polyethylene material, it will be useful for plastic covers, a bag, and packing film, and toy, and flexible bottles, and even a container, and electrical insulation, and moisture proofing, etc. Okay, and this polyethylene material also it will be used for the um electrical insulators are very important because its material is going to be used based on the thermal resistance of that material. And next one is polyvinyl chloride. So this is going to be useful for the pipes and fitting for water service, and usually for the flooring and ceiling panels and cable and cable jacket or fabric coating, etc. And also the polypropylene also it is going to be used for this. Suppose this is used for the vacuum flask and filament and fibers, and electrical insulator and flashlight casing, even for the hair dries, even for the air dryers and refrigerator and automotive parts. And for the Teflon, it is also used for the non-sticky coating pipes, anti-corrosion seals, gaskets, laboratory equipments, and bearing bushes, molding in craft, like that. And for the nylon, it is also used for the manufacturing of fibers and yarn, walls, bearings, containers, and electrical equipments, etc. Welcome to this thermoset plastic. Epoxy is one of the example. It is used as a insulating material and adhesive for joining and their work. And even for the phenol formaldehyde, also one of the plastic that is are going to use for the paint and other adhesive material, and vacuum cleaner parts and electrical parts, and handling the knobs for the domestic appliances, etc. So there is all about the applications of plastic. Then we'll move on to the next slide, that is the failure of plastics. Okay, so there are three types of failure of plastic. Reason first one is thermal degradation, second one is chemical degradation, and mechanical degradation. So let us discuss one by one in detail. So, like all materials, plastic to fail under the circumstance, and it is also essential to have prior knowledge regarding the various cause for failure, and the necessary precautions to be taken for avoiding the failures. Right. So, the various mechanism or cases of failure are grouped under some following conditions or headings. That is what thermal degradation. So this thermal degradation of polymer refers to the changes in molecular weight and molecular weight distribution of the polymer as a result of loss of hydrogen atoms from the polymer chain due to energy input from the heat. And photo oxidation and UV radiation is going to be taken for the ionizing radiation. So when this temperature exceeds a certain limit, the component of the long chain backbone of the polymer begin to separate and react with the another. So this is what the change of properties of the polymer. So we'll come to the chemical degradation. This results of exposure of plastic material to the atmospheric, whether it is aggressive operating or environmental involvement of various chemicals such as acids, alkali, and some salts. For even for the chemical degradation is also associated with the oxidation and hydrolysis of mechanism, as explained in a thermal degradation. So next one is mechanical degradation. So for the mechanical degradation, when this failure occurs when the product is exposed to an external force that are greater than the product is designed to handle. Okay, and ultimately it is resulting in the cracking or breaking of the plastic part. The most plastic tends to show the ductile behavior up to a certain load, and beyond this plastic become brittle, so which is can also make the prone of cracking and the breaking of that material. So this is all about the failure plastic, and let us will also we understood that what are the factors to be considered for the failure of the plastics. Okay, so for first one is the material selection and design and manufacturing process and service conditions. So what is material selection, how it is going to be affect this factor is going to be failure plastic, because while selecting this right plastic material, it depends upon the intended to use of plastic product. Okay, the type of load of producer will to be subjected to environment conditions and electrical and chemical aspects from the important factors. This manufacturer can select the material that will serve its appropriate functions. Okay, so while come to the design, this product must be designed keeping in intended to function in mind. However, this material also is going to be work properties must be given an equal interest by design engineers. Okay, even for the weight reduction or elimination of the fabrication and assembly steps, or providing the right wall or rib thickness of the even for the draft angles, etc., that during the plastic molding, the cost and finish of all of this product of a few important factors, and the poor design is the leading cause of plastic product failure. So we have to design in such a way that it will be appropriate design, then we can expect a longer duration of life of this product. And next one is the manufacturing process. So the particular manufacturing process must be taken into an account and maintain the fluidity of molten metal of the plastic, and avoiding the moisture trap and oxidation of the molten metal and residual stresses in the mold. So weak joining or welding process and other factor can result in a dramatically weakened product, so thereby shortening the projected lifespan of the product. And finally, the service condition. So we'll come to the service condition. In spite of the manuals and the specific directions regarding this product use, the failure of plastic can still occur as a result of inappropriate use or unintentional overextension of the products. So these are all some of the factors affecting on this plastic failure. And then we'll move on to the next slide, that is about different material. That is there are optical materials are there available. So these optical materials are used for the applications such as a lens, mirror, windows, prism, polarizer, detectors, and modulators, and etc. So this optical material serves to reflect or refract or transmit or disperse or polarize or detect and other transform light when allowed to pass the of this material. So these optical materials can also be classified into two types. One is traditional material and advanced or special material. Okay, so we will discuss what are the traditional material and advanced. Okay, so these traditional materials like glasses and plastics, although widely used in design of optics for visible radiation, however, this have a certain limitation due to their high absorption coefficient for light and infrared spectral range. This limitation has to be overcome with use of a special and advanced material and is going to be designed with the minimum possible of absorption coefficient for the infrared lights. So the group of categories we are going to discuss now. Again, first one is in optical material, the crystalline will be there, semiconductor and chalcogenide will be there. So what is crystalline? And this is the synthetic crystal growing technique have made available in single crystal such as lithium fluoride and even the calcium fluoride and potassium bromide are capable of transferring the optical radiation in the UV region, and many alkali halide crystals are capable of transferring the far infrared region. For the semiconductors, around the polystyrene forms of these semiconductor could be fabricated into windows, prism, and lens and domes by casting, grinding, and polishing of that product. So, this compound semiconductors such as gallium arsenide and ternary compounds such as gallium aluminum arsenide and even for the quaternary compounds such as indium gallium arsenide phosphide and now serve as a laser high emitting diodes and photodetectors. So this is all about semiconductors and chalcogenide optical materials or chalcogenide glasses. So you already know that it is around 2.5 micrometers of in the infrared red range. It is going to be from glass is going to be manufacturing, and here even although the it is discussed as a special material and possesses favorable properties, they have to certain limitations. So however, this choice of any particular material it depends upon the various optical properties like degree of transparency and refractive index, and along with this each property the special spectral dependency will be there. So and also we can uniformly of this material, the strength and hardness and temperature limits, hydroscopicity and chemical resistivity and availability of suitable coatings may also need to be considered for this optical materials. Then I will come to this thermal materials. Uh, these are possessing the favorable thermal properties in order to control and manage uh, heat and various applications. Hence it is very important to understand the various thermal properties which is material should possess in order to make a useful for the desired applications. Okay, first one is thermal capacity, thermal conductivity, and heat capacity, and thermal shock resistance, and the thermal expansion coefficient. These are all again some properties of thermal uh, properties of material.